We are moving on to linear application. This is going to be the fourth problem that you've seen. And you've seen videos for two of them, and then hopefully you've had a chance to do one of them on your own. And everything that we've done thus far has had a negative slope. So we started at some point and it was going down. Now what we're going to do is we're going to see a scenario where the slope is positive. Now something is going to be going up. So in order to do that, we are going to be looking at taking an Uber. So when you need a ride somewhere and you don't have a ride to get there, you can always call an Uber or a Lyft, or if you're really old school, they still have these things called taxis. However, not all rides are created equal. Sometimes you need just a short ride. It won't cost very much. Sometimes you need a longer ride. They usually cost more. Suppose a passenger in an Uber has looked at the cost of their rides, and they saw that a ride that goes for 4 miles cost them $12.05, and a ride that went for 7 miles costs $19.40. And we're going to make the assumption, this isn't always a perfect assumption, but we will assume this, the cost per mile is the same. Let's say you're downtown. Going a mile downtown isn't usually going to be the same as going a mile out on the highway. So cost per mile is the same. We're making that assumption. It's not always the case. Part A, what are two coordinates that you can write from the information given in this scenario? Well, we know that going on a ride that's 4 miles costs $12.05. Let's write that as a coordinate. A 4-mile ride costs $12.05. And a ride that is 7 miles costs $19.40. So we'll write that one out as well. A 7-mile ride costs $19.40. So there are two coordinates that we can write. And it's always important to define your variables and understand what x means and what y means. So x in this case, the 4 and the 7, those are just the miles of the ride. They took rides that were 4 miles, that were 7 miles. Those are the x coordinates. And the y coordinates, this 1205 and the 1940, what do those represent? Well, those are the cost of the ride. So x represents miles and y represents the cost. And as we've done before, we're going to calculate the equation of this line. So we're going to subtract the y coordinates on top. So we have 1940, subtract 1205, and we take 7 minus 4. So subtract the y's, that goes on top. Subtract the x's, that goes on the bottom. And if we subtract, we end up getting 735 over 3. And what we're going to do is we're going to divide these again. So 735 divided by 3. If we divide these, we get 2.45. And that's going to be our slope. And we'll interpret what that slope means in a little bit. Let's move on to finding our y-intercept. We're going to start with y equals mx plus b. And you can pick either of these 2 points. I'm going to pick the first one. The y-coordinate is going to be 1205. The m represents the slope. That's what we just found over there. That's 245. The x is the x-coordinate from this point, which we see as a 4. So we replace that with a 4, and we still have plus b. Now we're going to simplify it. We have 1205 equals, we can take 245 and we can multiply it by 4, and I think we get 980. Your calculator might tell you 9.8, but since we're dealing with money, I'm going to put the 0 there. Represents 80 cents. And to solve for b, we're going to get rid of this 980 by subtracting it. And if you do that, we get a b value of, this is going to be 2.25. And that's your y-intercept, which again, we will interpret in just a second. So the final equation that we need to know is y equals 2.45x. Take your slope, put it there next to an x, and then plug in your y-intercept, 2.25. And this is your final equation, which we will use for the rest of this problem. First question asks, what is the y-intercept? Well, here's your y-intercept over here. So our y-intercept is 0, 2.25. I think it helps writing it as a coordinate. 0 is the x, 225 is the y. Remember, x represents how many miles you go. If you go for 0 miles, it's still going to cost you $2.25. So just to pick you up, that Uber driver has to get to your place. You know, even though they're not taking you anywhere yet, they're basically paying $2.25 for them just to meet you where you are. So what this means is a ride that is 0 miles still costs $2.25. So that's basically their fee just to come to you and pick you up. Part E, what is the slope of your equation? Slope is always very important. Another word for slope, you can think of it as like the rate at which something's changing. So if you look here, the slope is 2.45. Let's just write that out. The slope is 2.45. Another way of thinking of this is, think of it as 2.45 over 1. And this is how much the y changes, and this is how much the x changes. Remember, slope is the change in y over the change in x. So the y, remember that represents the cost. So the cost is increasing by 2.45 for every 1 mile. Remember, x represents the number of miles. So essentially, it's just saying each mile in an Uber costs $2.45. So each mile increases the cost by $2.45. So again, whenever I'm describing the slope, I like to use that word each. And let's move down to the x-intercept. Hopefully you know the drill by now. To find an x-intercept, we're going to start with the equation y equals 2.45x plus 225. To find an x-intercept, all we have to do is change this y to a 0. And then we're going to solve for the x. So we're going to subtract 225 from both sides. And we get negative 2.25 equals 2.45x. And you'll notice something weird happening here as we do this, and that's fine. Here's 2.45. We'll divide it on both sides. And if we divide these, we end up getting x equals negative 0.92. Now, it's not the decimal that makes this weird. We can have decimals for answers, that's fine. But let's go ahead and write this as a coordinate and try and interpret it. It would be negative 0.92, comma 0. This is your x-intercept. So what this means is, if you take a ride that is negative 0.92 miles, it's going to cost $0. Could you ever take a ride in an Uber that goes negative miles? No, distance can't be negative. So why does this seem unrealistic? You're never going to have a ride that goes negative miles. Later on in this assignment, you're going to end up graphing this, and you'll end up seeing this on the graph, but I'll show you just a quick visual of what it will look like. The cost of that Uber starts here at $2.25. Remember, that's their cost just to pick you up. And every mile that you get, it's increasing the total cost. What we just found with that x-intercept was way back here. That's the x-intercept. That's not really very usable for us because you can't have a ride that's negative. So we only worry about positive values of x in this scenario. Again, it changes for each scenario, so you have to be able to interpret it. Part G, how much will a ride cost if you need to travel for 13 miles? So let's go ahead and write our equation out again. Y equals, try that one more time. Y equals 2.45 x plus 2.25. And then we are going to need to travel 13 miles. Which variable, x or y, represented the miles? That's right, the x represented miles. So I'm going to replace x with 13. So we have y equals 2.45, replace the x with a 13, plus 225. And then we're going to take that 245 and we're going to multiply it by 13. And that gives us 3185. But then we still have to add in that 225 that they charge to pick you up. And if you add those together, we get 34.1 is what your calculator will show you. Since it's talking about money, we'll make it 34.10. So final answer for this one, a 13-mile ride will cost $34.10. And let's move on one more. We have, oh, this is an expensive ride. This ride costs $42.92. I want to know, how far did this ride take you? Let's start with the blank copy of the formula. We get y equals 2.45x plus 2.25. Now, what we do know in this problem is that the amount of this ride, the cost was $42.92. Is that the x or the y? Well, yeah, the other one we did was x, so this is probably y. So the y, which is represented by the cost, is $42.92. We can replace y with the cost. And then we get equals 2.45x plus 2.25. And then what we can do is we can subtract both sides by 2.25. And if you subtract 2.25, it's going to give you 40.67 equals 2.45x. To solve, we can just divide by 2.45, divide by 2.45, and if we divide, we end up with x equals 16.6. So we would say a ride that cost $42.92, I think. $42.92, an expensive ride that went 16.6 miles. And that's how you interpret that one. So once again, you've still got the graph to go ahead and do. So plot your couple points from part A, graph the equation from part C, and hopefully that line goes right through those two dots. And then when you're done, post a screenshot, and then you're all set with this one. And then you've got one to try on your own. Good luck, everyone.